Hi, I'm Stefan Eeskens. I'm an Azure specialist and a Microsoft MVP. I have a particular interest for artificial intelligence. I have been involved in several AI-related real-world projects in the past 3 years. Therefore, I want to share some lessons learned and of course some technical bits with the community. Please follow me on Twitter as I'll keep sharing extra bits and I'll be announcing the upcoming of new episodes. This course is made of multiple episodes and some of them might not be recorded yet by the time you watch the current episode. The course explains some fundamental AI concepts and will slowly increase in complexity with real-world examples and concrete business scenarios that could be relevant to your enterprise. You will learn how to create and consume Azure Cognitive Services, as well as how to educate more advanced services and specialize them to fit your specific needs. No technical prerequisite is necessary, as I will try to be as exhaustive as possible in my explanations. However, the course is primarily intended to developers, but part of it is accessible to non-developers as well. For this episode, I have created another chatbot that is aimed at helping factory workers to intervene on machines whenever they encounter operating problems. This factory comes with a specific jargon, and workers are surrounded by permanent noise, which can obfuscate worker statements when they give vocal orders. We'll tackle these constraints by leveraging the custom speech service with the bot framework. We'll also see how custom speech differs from speech priming that I talked about in episode 8. If you're not yet familiar with the bot framework and the cognitive services in general, I strongly advise you to watch my other episodes, as I will only focus on custom speech and I will not explain things that I have already explained in the previous episodes. Before diving into demo mode, let's see what custom speech has to offer. Custom speech comes with language models, in other words, models that let you specify the most common utterances used in your business scenario. It is very similar to how you define your Lewis utterances. If you associate your bot with the Lewis application, you could inject your Lewis utterances into a language model. You'll need to rework it a little bit because the data format is a bit different. Acoustic models help tackling important things. In my business scenario, the users are factory workers surrounded by permanent noise emitted by machines. I have created a model that takes into account that background noise, and I'll show you how it works later on. Acoustic models may also be used to make the speech service familiar with your users. Indeed, if you know that only 10 factory workers are users of your chatbot, you might want them to record a few phrases in real conditions so that the model becomes familiar with their way of speaking. At last, custom speech comes with a very handy feature that allows you to define custom pronunciation data. You should not use that against well-known words, but rather against specific business jargon. In my scenario, I will use it to define the names of my machines, which are very special. In the previous episode, we used speech priming, which is very easy to activate at bot level. However, although it will cover 99% of the use cases, it might not be ideal for the factory scenario I've just described. Indeed, speech priming only covers the language part. Don't get me wrong, when I say only, it's already a tremendous thing. But priming will not be able to tackle acoustic conditions nor internal ways of pronunciating things. Okay, before seeing how to build a custom speech service, let's see it in action first. But I have the following disclaimer. For the purpose of the demo, I will be using an audio recording with background noise that is really ears unfriendly. I have already lowered down the volume, but it's still not very pleasant. So now that you're warned, I've got two tabs, one with a web chat control pointing to my custom speech service, and the other tab is using Google Speech with the built-in speech recognizer of Chrome that I showed in episode 8. I will play the audio recording with both of them, to see how it's interpreted by each.
What to do when bat is down.
As you can see, the custom speech service did understand the question correctly. Even better, you might have noticed that I said the word bat, which is the nickname of Batley Boy, one of my machines, and the custom speech service auto-resolved bat to Batley Boy. Now let's switch to Chrome's built-in speech recognizer and play the same audio.
What to do when bat is down.
As you can see, Chrome's understanding is quite far from the truth. With some of the recordings, it's even not recognizing a single word. This is most probably due to the background noise that perturbates the recognizer. Let's now try to give another order to the chatbot using custom speech again, but this time it will be my voice without background noise.
How to restart FJ?
As you might have noticed, I said FJ, and here again it was resolved to Fuji by the speech service. Let's ask the same thing to Chrome.
How to restart FJ?
Here the recognition is much better than with the audio recording, but FJ was not translated to the machine name because Chrome is not aware of any custom pronunciation data. So this showed you a glimpse of what you can expect with custom speech service. And here I really built very minimal speech models, as we will see in a minute. Here is a recap of all the steps I will be demoing in a minute. We first need to create a custom speech service. Then we'll create our speech models in order to specialize the speech service to our specific factory needs. We'll then deploy the service. We'll finish by integrating our service with the web chat control that is available on GitHub. It will require some code change at web chat level. I have already created a custom speech service, which is nothing else but creating a cognitive service and choose a custom speech API. We've already seen how to create cognitive services in the previous episode, so it's not needed to show it again. I have taken the free pricing tier as it will be enough for my demo. Beware that although custom speech is still in preview, it's already possible to purchase the standard tier. For the time being, it is possible to go up to 100 scale units, which enables you to play 500 concurrent recognitions for an average price of 550 euros a day. So, with that already in place, we can expect custom speech to become generally available soon or later. It is necessary to choose a standard tier when you plan to have more than one deployment. However, you can work with lower scale units to limit the cost, depending on your consumption needs, of course. As usual, once created, you will need to grab the subscription key, but we'll come back to this screen later on. I'll show you later how to create speech models, but let's first have a look at the raw data. I have already recorded a few WAV files with some background noise to mimic the noise of the factory. You can use any recording tool, but remember that for the time being, there are a few major constraints. The file must be in a WAV format. The sampling rate must be between 8 and 16 kHz, and the recording should be in mono, not stereo. At last, each WAV file shouldn't exceed 1 minute. Let's have a look at our language data. As explained earlier, the language data is similar to Lewis intents. You should define here the most common phrases your application or bot will be dealing with. Here I just specified a few utterances. Note that this is strongly recommended to define a language model, although this is not mandatory. The only reason why you shouldn't be creating a language model is when you want to have a generic speech recognizer with specific acoustic conditions. In this pronunciation data file, I have specified the names of my machines and the way they should be pronounced. Batley Boy can be resolved to Bat, while Fuji can simply be said FJ. As you understood, the display form must be followed by the phonetic form. Each WAV file must have its corresponding transcript. Although this might look redundant with the language data, it's not, as you can decide to record only a certain proportion of all the possible utterances your application might be dealing with. Remember that the audio data is especially there to take into account specific acoustic conditions or things like specific accents when speaking. If none of these are important for you, you can simply skip the acoustic model, but in that case, make sure to consider speech priming that we've seen in a previous episode if you're working with chatbots, as it is much easier to put in place. If you're not working with the bot framework, then custom speech remains your best option to specify your language model. I'm now in the custom speech UI. If I navigate to the adaptation data, I see all the datasets I already have. In this case, I have none. Let's try to import a language dataset. As you can see, the UI complains about the fact that there is no subscription, so it's time to grab the subscription key of our custom speech service. So I'm gonna copy the custom speech service subscription key and add it here. Now my UI is bound to my service. Okay, let's now import our language dataset. I will directly add the pronunciation data. I'll finish with the acoustic dataset. All the audio files must be zipped into a single archive prior to uploading the dataset. Now we need to wait a little bit for the datasets to be processed. Once all the datasets are processed, we can create our models. It is very easy and intuitive to create these. Here again, we need to wait a little bit before the models are ready to use. Once ready, it's time to create a deployment. Again, it's just a matter of a few clicks to get it done. Once the deployment completes, you need to grab some information from the detailed view. Two information are key here: the subscription key that will pass to the speech recognizer instance later on, and the host header of the WebSocket API consumed from a JavaScript client. Indeed, as I told you in the recap slide, we will customize the website control of the bot framework in order to talk to this endpoint. Okay, time for a break. We've already done these 3 steps. The only remaining part, but that can be the most tedious one, is to download the website control, modify it, host it and test it. Take a breath and let's get it done. We're now gonna see how to customize the website control. The first thing to do is to navigate to the GitHub repository of the website control. I have already downloaded the code locally on my machine and extracted it to a local folder. Similarly to what we did in the previous episode, I created an IIS web application locally that points to this folder. It's now time to open this folder with Visual Studio Code. The first thing I did is to open the default speech example page located in sample/speech folder in order to provide my own subscription keys. Note here that I provided the subscription key of my custom speech service for the recognizer part, while I provided a standard Bing speech key for the synthesizer part. Next, I changed the way the default recognition of the website control works, as I noticed that the default code plumbing fails when interacting with an instance of the custom speech service, as it sends unexpected data to the service. I queued an issue in the GitHub repository and provided my solution as a workaround, but no one from Microsoft ever reacted so far. At last, I replaced the default endpoint targeting the standard speech service with the host header information I told you about earlier. Note that customizing the website control this way restricts its usage to the custom speech service only. I chose the easiest solution here. A better approach would be to extend it so that it can support the standard speech and the custom speech at the same time. We can also expect Microsoft to address this in the near future. With all the changes made, the only thing left is to rebuild the website control using npm build. Note that you should of course install npm on your machine before you can start rebuilding the website control. Once the build is complete, the website control should be able to talk directly to your custom speech service, as we saw in the demo I made in the beginning of this episode. Okay, time to wrap it up. The key takeaway of this session is that you should always privilege speech rhyming over custom speech whenever possible, meaning as soon as you are using the bot framework, and that you don't have specific acoustic requirements. However, when you have specific acoustic conditions, or whether you are not dealing with the bot framework, then custom speech is your friend. Do not hesitate to follow me on Twitter and to share your thoughts.